In the last 6 months, over 1.5 million API keys and user files were exposed because of poorly set up AI platforms. The recent OpenClaw mania left more than 135,000 instances with the door wide open. Even the darling AI automation platform, NA10, was not spared. In the last few weeks, 2 major security flaws were discovered, one of which was critical, codenamed Nightmare. This left more than 100,000 systems at risk to complete data loss, giving hackers access to everything: emails, databases, and all files, including CRM records and financial statements. To access these unprotected systems, all you need is an internet connection. Quick YouTube tutorials show you how to get AI running fast, but they ignore security. I want to help you avoid this. In this video, I will show you exactly how to protect your AI infrastructure. First, we will look at the real-world risks and heavy penalties of losing your own personal data, or worse, your client's data. Then, I will take you step by step through 6 different security setups. We will start simple and build up to top-level security. I'll provide clear visual diagrams for each stage, so you can easily see how everything connects and evolves. I've been working in IT development for over 20 years, handling also the setup and security of software for everyone, from small businesses to large enterprises in finance and government. Lately, I'm helping business owners identifying where AI can help with their operations, building and deploying for them the solutions they need. We will focus on securing NA10, but this works for any app, system, or even a SaaS you might build. And make sure you stick around until the end, as I'll share 2 bonus methods to securely access your web admin dashboards without exposing them to the public internet. I've added timestamps in the description for each section, so feel free to jump around to the parts you need most. Okay, so why should you care? For example, when you are making some automations that handle only your personal data, then you should say, okay, it's just my own private data, so it's my choice, right? Yes, that's totally correct. So you are responsible with your own data and you are freely to choose what you want to do with your personal data. But even so, using your personal data in unprotected systems can lead to leaks, and hackers can steal your personal info, identity, and credential. What do I mean by identity? Consider that now, with the help of AI, the hackers can interpolate all the data that they find about you and they gather or steal about you, and they will make a very complete personal file about yourself. And now with AI, it's very easy to do that. So the hackers are very smart at using AI to build this identity profile of yourself. Imagine what security agencies would have done the same a few years ago. The hackers with AI can do now very easy and very cheap. So they gather all the information about you, like social posting that you do, that it is already available online. So they can gather your personal preferences about anything. If they steal then your email credentials, they can find out basically whatever you connect and you chat on the mail. So that means your personal relationships, even your work relationships and work related activity, your business if you have one, or whatever you would plan to do. They can easily find out what are your desires and most importantly what you are afraid of, and they can use all this information to build this profile on you and exploit it later. And if once, for example, they steal your email credentials, for example, or your Facebook credentials, they can impersonate you and create other accounts on other platforms by to create the accounts using Google or Facebook authenticators. And with this profile, imagine that the hackers they can sell your profile to other exploiters, other hackers that can harness this information and try to exploit it further. So it doesn't mean that the same hacker that stole your identity or information is the same that will try to exploit it. Some will just take your data and then sell it, and others will exploit it. Another thing to be aware of is ransom extortion. So if you have sensitive information, I don't know, personal information or relationship details with people that you shouldn't have, or compromising photos, either personal or work related, that shouldn't get outside the work environment, or financial information about your savings or your transactions, whether legal or borderline legal or completely illegal, depending on what you have in the profile. They can extort you, saying, okay, we have this information, we will make it public or share it with the authorities or the other persons who are related to that information. And if you don't comply, they will ask you money for them not to do so. Of course, this can end up in a loop, like they will ask for more money and for more money, and you get the picture. So once your personal information gets into the dark web of the hackers and exploiters, it is very, very hard to get out of there. So you would have to change your ID, your phone number, your email, everything related to yourself that was compromised. And imagine that takes a lot of time, headaches, and some information cannot be changed, like your social security number or your face, in case they steal your ID information. Your picture is the same, and they can use AI to make other pictures of yourself. And also your voice barely changes, mainly perhaps as you age, but still they would be able to adapt it as you age with AI. And with voice, here is something very dangerous that the hackers are already starting to take advantage of. So if they take some words of you speaking and they just need a few sentences to clone your voice, so either if you have your voice on publicly on social media, or they steal recordings of your voice or a video where you are speaking, they can clone your voice, and using the identity and the profile they have on you, they would simply call your relatives, like the closest ones, your parents or your siblings, with your own voice, saying, okay, hey mom, I had an emergency, so I need some emergency money right now to get out of these issues. And here you can send the money in this account or via Western Union or whatever. And your parents, hearing your voice and seeing that you are in trouble, they will send the money. Of course, the hackers are smart and will not ask for huge amount of money that they will question whether it is you that, or why are you asking for such a large amount of money. But they are smart and will know what amount of money to ask, and maybe if they get one tranche of your money, then maybe can ask for another payment and another until they figure it out. But by that time the money already sent, it is gone. And of course your reputation will be damaged. Imagine if they break into your calendar and your agenda, where you have the details of your other contacts like friends, business partners, colleagues. They can also be exposed to data leaks, and of course they will not be happy in case they find out that the leak came from you. They can also post on social media on your behalf, and they can post damaging information either about yourself or the others. So imagine if they want to hurt you, they can do it, but until your social media followers will eventually find out that it wasn't you that actually posted that information. Until then, it can take a while, and your followers will actually think that those were your posts, and your reputation will be damaged. And as you know, once you lose trust, it is very, very hard to earn it. And remember, you can expose also the information of other people, not just yourself. Imagine they can steal your contacts, meaning they can get the email addresses and phone numbers of all the people in your agenda. So you have to be careful with that as well. And as a summary, just because you're handling and using only your personal data, that doesn't mean it is safe just because it's your own data. Attackers will exploit it for financial gain, fraud, and of course reputational damage. Okay, now if you didn't care that much for your personal information, then that's fine. But when you're handling other people's data, or for your business that of course handles other people's data, the situation gets more serious because you are often required by law to protect customer data. So whether you want it or not, you must protect that data, and failing to do so, it can result in serious consequences. While will not cover regulatory standards imposing data security, here are brief descriptions of GDPR and HIPAA. GDPR covers any information that can identify a person, like email address, IP address, home address, while HIPAA specifically protects identifiable health information. Such data is medical records, your known health conditions, prescription history, lab test results. GDPR is for European clients, so you don't have to be a European citizen to comply with this requirement. You just need to handle the personal data of European people. So the GDPR can fine up to 4% of your global turnover or 20 million, whichever is highest. HIPAA is based for US customers, and it can add up to 1.5 million per year. And of course, there are other regulatory mandatory standards that you must obey. And beside these fines that you can get from the regulators, companies representing the clients that you provide business to, they can also file lawsuits against you where they will claim money or assets or whatever against you. So imagine the time and money just the lawsuits imply, and of course the compensations that you have to pay. And as for your business, imagine that while the regulators make their investigations, you will need to stop your business. So just take into account the money that you will lose while your business is being stopped. And you have to be very careful with your personal assets, because in some countries you are allowed to provide business for other people on your personal identity, meaning you are not obligated to have a company which has limited liability. So when you are doing business with your personal identity, with your own person, then all your personal assets can be at risk because you are being sued personally. Then your personal assets can be taken. Imagine your savings, your property, like your house, your land if you have, or your car. Everything that you have can be taken away depending on the severity of the data leak that you caused. And of course, a data leak can make your customers lose their trust in you. So they will go to other competitors that didn't have such data leaks. Of course, people will complain on social media about security breach that your service was affected by. So that will affect your social profile as well. And of course, with all these in mind, imagine that it will be much difficult in the future to win new business. Again, once you lose the trust of your clients, it will be very, very difficult to earn it back. And if you are wondering how can such an investigation start, just imagine customers can file complaints or known breaches that are being investigated, and those investigations can lead to your own business. So imagine it as a web where the investigators follow one lead, and that lead leads to many other leads, and at some point that one leads to your own deployment, and they find out that of course your own deployment was not secured as it should, and you will get audited. And maybe, who knows, maybe one of your competitors, which has clear evidence that you are not protecting your systems as you should, either you say it on social media or it is obvious in what you post, or maybe they, I don't know, use some other, let's say, ethical hacking techniques, and they can see that clearly you are not protecting as you should the system. They can file for a complaint, and the regulators will come and audit, and you can get into trouble. So be careful, because in business contexts, failing to secure systems can cost far more than fines, including legal liability, loss of customer trust, and long-term reputational damage. Okay, so now that we covered the risks, then you would argue, okay, those are hypothetical risks. Doesn't mean that it can happen. But on this slide, I will show you the exact actual numbers of incidents where data was leaked because of improper security measures. And the AI adoption only makes the things worse, because many people get into the AI space and they deploy AI solutions. But unfortunately, people either are not aware or don't have time to properly secure their environments. And I hope this video will clarify the risks and the actual steps that people can use in their environments. So just a quick overview. Only in the last 6 months alone, 1.5 million API keys and user data was exposed. With the latest OpenClaw mania in the last weeks, around 135,000 OpenClaw instances were exploitable, and even around 70% of organizations have experienced AI-linked data. This, of course, happened mostly in small to medium businesses, because they don't have that much regulation and enforced security policies in place, like the big and the companies and the corporations. And of course, employees wanting to automate and make their work more productive, they used public AI models, which led to data leaks outside of the company. And even the darling N8N automation server was not spared from vulnerabilities. Just alone, the latest critical vulnerability, which had its very proper codename, Nightmare, had more than 100,000 instances exposed. So this was as of 6 February. These numbers are provided by the Shadow Server Foundation on a scan they ran on 9th of January, so not on 6th of February. So I will modify this like this. So now it's correct. And guess what? Even after the first scan, later scans suggested that half of the instances remained the same, with the same online security measures in place and not even patched. And here just a quick overview of the recent vulnerabilities on N8N that were discovered in the last weeks. So we have the infamous nightmare where basically any unauthenticated user could steal basically everything. Your secret, they can become admin, run server commands. So just imagine what they could steal. So if you're automating workflows where you have your API keys exposed, like to the Gmail, Google Drive, even your database, your access to your CRM, your files on the N8N, those are just sitting out there on the internet, just waiting for them to be just taken. And we had another vulnerability where a user must be logged in N8N, but this means that even a regular user exploiting this vulnerability can get admin access and basically have access to everything that is stored there, all your keys, your data, your databases, everything. And even so, a regular user account is being hacked and exploited and sold on the dark web, then of course that account can be used with this vulnerability to give admin access to outside hacker that doesn't have an authorized account on N8N. So this is just an overview of the seriousness of not protecting your N8N server. So basically all the credentials and API keys that you use in your N8N automations are exposed to hackers, and without proper security measures in place, they are very, very easy to get. So be very careful with your security setup. So yes, as we previously discussed, be very careful with your N8N server configuration. N8N is of course powerful and a simple and efficient automation tool, but as we covered, be careful because every automation that you make and all the systems that you use in your automations, all the credentials for those systems, like your mail, documents, files, database, and any other system that you interconnect with, all those credentials are being exposed on the N8N server. So even a single mistake can lead to full infrastructure compromise. So be very careful. Of course, N8N is powerful, but as any new and young software, they evolve quickly. Security issues are expected early on. And of course, the system being new, some bugs are being reported way longer after they are being found. So that leaves a big gap for attackers to take advantage. And how can you protect yourself? Prevention is critical. As with your health, it is way better to prevent something than to fix. Most part of the prevention implies isolation, so you should isolate your server as much as possible from the public access. And of course, follow the industry standards for security. And these are standards that you can apply for any web app, for any deployment, any type of application or service that you want to deploy. This is generally applicable for any type of deployment, not just N8N. So if you're planning on creating your own SaaS or making just a service that is accessible via API, all the security standards and architectures that we will explore in this video, you can apply them as well. And a quick tip, there are many deployment tutorials online where they make it very easy for you to deploy the N8N server, which indeed is fine as long as you deploy it locally and only put some test data in there. So in case of a breach, you just lose dummy test data. That is fine. But once you deploy n8n and plan it as a production server where you will store actual data, whether you're personal or for business use, then it is crucial that you follow these security standards. And an overview of the security practices and security architectures that we'll cover. I won't go here into much details because we will go on each one of them, where I will give you a brief explanation of what it entails, and then I will show you clearly the diagram architecture for this security measure. And as a bonus, I will show you how to securely access the web admin interface of n8n or of any deployment server, because most of the time all the servers must have an administration web console where administrators can log in and configure and change the service. This is important to know. I will explain how to basically isolate and secure your n8n server, but then you might question yourself, okay, if I isolate the n8n so good, then how can I access the admin console to actually make changes? So I will cover that as well. But before we dig into the details, I will show you here what I mean by those simple deployments that most of the YouTube videos present. So we have here the browser where, let's say, usually for these deployments, the developers make a dashboard with all the available n8n automations they can start, where they can specify, of course, the automation to start and with different parameters. And this dashboard, of course, it will call the n8n server. We have here the UI server, basically the server hosting the UI for the browser to display. Here the UI server and the n8n server can be the same server, but for isolation and to clearly show it, I will display it as two separate servers. And just imagine some developers don't even protect the UI server with username and password. Maybe because doing so, it requires them to have an authentication module with a database in the backend to hold the users and their passwords. But even so, with only a simple Nginx configuration, you can protect your UI with username and password. Of course, you can watch one of my previous videos where I explain how to secure your Supabase instance. There is a chapter where I go into the details of how you can set up Nginx and protect the browser with your username and password. Very easy to do, very simple. Go and check that out. And of course, you might wonder what is wrong with this configuration. Well, first of all, all the endpoints a browser can access, they are being publicly available to the user of the browser. So the user, or in this case the attacker, can just go into the browser and go and check the page source code. And then, of course, you can see exactly all the links or actual the endpoints the n8n server is going to be used for. Lately, there is a more dynamic page rendering, and you cannot see as easy as before the endpoints being called, but still you can go and check in the browser with the developer tools. You have there a network tab where you can see in real time the n8n endpoints being called. So of course, after that, the attacker can take those endpoints and search them for vulnerabilities. And even so, this is one route the attacker can take by accessing the UI in front of the n8n server, but the attacker can take another route to directly exploit and scan for the N8N servers. And you might wonder how one attacker can do that. Just to find out your N8N server is simple, because they use broadly server scanners for N8N servers, and they can find these instances that they can scan, or a range of IPs of instances that they can scan. So either through their dark web databases, where hackers make available for other hackers IP ranges of N8N server deployments, or they just know, and this data is publicly available, they know the IP ranges of the most commonly used deployment providers that unexperienced users use, like on Replit, DigitalOcean, and so on. But to give you a better overview of these platforms, why they are being targeted is because these deployment platforms, they are easy, cheap, and heavily tutorial driven. What that tutorial driven means is because on YouTube there are a lot of tutorials where they explain how to easily deploy N8N or other AI service for beginners, and of course the hackers target these type of tutorials because usually beginners lack the experience to properly secure their environments. And of course the hackers monitor those YouTube channels for beginners, and this is again very easy today with AI and scraping tools that they can easily get this information. What are these, how I call them, one-click platforms? Just to name a few: Replit, DigitalOcean, Railway, Render. I'm not saying these are not reputable and dependable services. I'm just saying because they're of their nature to have it very easy for users to deploy services on them, they make it more, let's say, appealing to hackers to target these providers to scan their ports for unsecured N8N instances. Again, like I said, what IP ranges all these internet cloud providers use, that information is publicly available. And if not, of course, like I said, hackers share this information amongst them. And of course, even the big players on cloud platforms, like the ones provided by Amazon, Google, and Microsoft, those are also being targeted by the hackers because, of course, beginners also use them. So yes, these are the two paths a hacker can take to identify your N8N server, either via the browser with the code page or the network tab. They can see exactly what N8N endpoints the browser is calling. And this other route where they just target the publicly available N8N servers, like I said, by scanning the IP ranges of those cloud providers. Okay, so now that we have clarified the worst security architecture that you can have in place, I will go then over the next architectural security standards that you can actually use, and I will go over from the most common and easy security measure you can take to the most secure but more difficult to implement practice. And I must stress that as many as these security measures you take in place, the more secure your deployment will be, because the hacker will have to hack each of these security measures one by one. So if he hacks the first layer, then of course he will have the next, let's say, 6 layers. Then he hacks the next layer, then he will have 5 layers, and so on. And maybe at some point either he doesn't have time or cannot hack a layer or just gives up. So the more security layers you have in place, the better for your overall security. Okay, so security practice number 1. You should use the public frontend and the private backend architecture. What does this mean? So basically, only the front-end web app is public. The backend is completely separated from the front-end, and by that I mean only the backend actually controls when and how n8n is being called. Of course, all internal services must authenticate, no anonymous backend calls, and of course all traffic is encrypted. So now let's go over the diagram. Again, all this is in the public internet. So everything is accessible to everyone, including hackers. So as before, we have the browser, we have the UI server, which again, they can be the same as this backend server, and the UI server can be the same. But here I put them as separate for better visibility. The UI server mandatory to be user and password protected, either with a simple Nginx configuration or either using proper user management system. Here we have the backend server that is being called by the UI server. So what does this mean is when the hacker will check the browser and the network tab to see what APIs are being called, he will only see the APIs of this backend server. He will not be able to see the endpoints of the n8n server because the backend server in its own code will have hard-coded, so the logic is available inside this server, so the hacker will not be able to see the n8n endpoints. He will only be able to see the publicly available backend API endpoints on this server, and that's it. What this server does internally to call n8n server is completely invisible to the hacker. But then again, you may ask, okay, how can the hacker find the n8n server? The same as before, he can use the scanner to scan IP ranges of commonly used internet cloud providers to find your n8n server directly. Because as I said, all of these are in the internet public space. So everything is accessible, but this time around, the former route that I explained previously is not available anymore because from the browser route, he can only access these backend APIs. And of course, the communication between all the servers must be encrypted with HTTPS and authenticated properly with API keys or API secrets. The next security practice is one of the most important ones and easy to achieve by using a reputable cloud provider is by using a virtual private cloud. VPC refers to a logically isolated private network inside a public cloud provider. In simple terms, you can see it as your own private network with its own subnets, routing tables, firewalls, private IPs inside public cloud's provider infrastructure. So even though you are using a public cloud, your resources can run in private subnets, be inaccessible from the public internet, and of course communicate securely with each other. So you can define your VPC with IP ranges and subnets that are private and accessible only within the cloud provider, not from the internet. With the routing and firewall rules, and most importantly, all these services inside the VPC are completely unreachable from the internet. Usually the VPC comes with advanced firewall rules. Don't worry about this. The cloud provider will provide as well the firewall that will be part of the VPC. And of course, all these features are required for any serious hosting provider. So use only cloud providers that actually provide a VPC with all these functionalities: IP ranges, private subnets, routing and firewalls and an interface to easily manage and separate and isolate the VPC from the public internet. And now let's go over the diagram. So now, as you can see, we have here the internet, the public space, only this part where you only have the browser and the UI server that is rendering the browser. And in the virtual private network, you will deploy your backend server and your n8n server. For the backend server, of course, you will have to make some endpoints available to the UI server to be able to accomplish your functionalities, but that's it. In this VPC, you only specify which endpoints from this server only are being accessible from the internet. All the other endpoints and functionalities of the server will be completely inaccessible to the internet. And of course, this n8n server will be completely inaccessible. It will be only in the VPC, and no endpoints of this n8n server will be publicly available. Like I said, only the mandatory backend APIs or resources endpoints to this backend server will be made available to the internet to be able to be accessible in the browser. And that's it. Everything related to the n8n server is completely private. So in this case, the attacker won't be able to scan the IP ranges and find your n8n server because this n8n server is using its own private IP inside this private VPC. So I stress again, this is one of the most important and most effective ways to achieve isolation for your n8n server. This would be the most important and mandatory security architecture you must have in place. So use cloud provider that has the VPC functionality and isolate your n8n server like this. So this is the most simple and most efficient way to secure your services online. Security practice number 3. Use a plain old good firewall. This rule is absolutely mandatory. Even the basic inbound rules matter because you can restrict access to your services to only some specific IPs or ranges of IPs. And also, of course, restrict access by ports as well. Now, if you wonder where can you get a firewall, you can either use the built-in firewall from Unix, and all the cloud providers deploy servers with Unix, or use the firewalls that come as part of the VPC. So that's why it's crucial to avoid cloud providers that don't provide the VPC functionality and also don't provide the firewall functionality within the PC. So avoid at all costs providers that don't have the VPC functionality, and especially those that don't have the firewall functionality within each VPC. And as a bonus to using the VPCs provided by the cloud providers, usually the VPCs come with additional firewall rules that are built in, so you can use right away. And all these rules make it easier for you to allow or block traffic coming from other VPCs that you define, and also to or from services offered by the cloud provider. So if you have a database already hosted by the same cloud provider, then you can easily configure it in the firewall of the VPC. And this goes for any other service offered by the cloud provider. And now let's check the diagram. So you see we added here all these 3 firewalls, 1, 2, 3. This one between the browser and the UI server, so the firewall that basically protects the UI server. is optional, meaning that usually when you have a public-facing UI, you allow it to the whole internet. So it's not blocked in any way. But in case you have a UI that is supposed to be used only by internal employees, for example, then you would add this firewall to add extra firewall rules. For example, I mentioned previously IP ranges. So in case you want to restrict only for some employees, or in case you have multiple branches of your company, then the IP ranges would be the IP ranges allocated for those specific branches, or just IP ranges that your clients might use. In case the clients use IPs from different ranges, then you would have to specify individual IPs, not ranges. And the same here, we have a firewall between the UI server and the backend server. So this protects the backend server, and another firewall here before the anytent server. So here you can specify all the rules that you need for these firewalls. For example, for this anytent server, you could easily specify that, okay, I only want to allow traffic coming from the IP address of the backend server. The same here, you allow only traffic coming from the IP of the UI server. Here between the UI server and the backend server, you can also limit the ports being used, meaning you can specify, okay, I want only the HTTPS port to be allowed to communicate between these two servers, as you only have the UI accessing the backend server through the HTTPS port. Also, a quick note here, usually all these firewalls come with built-in load balancing rules and also some denial of service protection methods. This depends on the cloud provider you choose, but most of them provide this functionality out of the box, or you can purchase separate packages where these firewalls act also as a load balancer, meaning in case you have here a cluster of multiple backend servers, the firewall will manage the traffic to all these backend servers, so no one specific server will be overwhelmed by the traffic. And also they provide denial of service attacks, meaning in case a hacker tries to brute force your backend server, then that traffic will be stopped. And you can also configure those IPs that are used for the attacks to be automatically added to a block list. So next time when the attacker will try to brute force your system again, they will be cut off immediately from the start of the connection. Security practice number 4. Use security certificates. Well, if you wonder what are those, are just files that provide the identity of a server. You can think of it as a digital ID card for a specific server. These security certificates also enable the encryption of the data that goes between the two servers. And we have two cryptographic protocols that ensure the encryption of the data. We have TLS, Transport Layer Security, that is used mainly on browser-to-server communication, and it is used by default by HTTPS. Here only one certificate is needed, only the server's certificate, the front-end server certificate. Usually the server certificate must be issued by a known trust authority, so that's why you will not get a security warning when you access the website. And the other cryptographic protocol is mTLS, which is a mutual TLS. It is mutual because we need two certificates for both servers. And this is the gold standard in server-to-server communications, where you use the certificates to identify a server and to encrypt the data that is exchanged between two servers. And another huge benefit we get by using certificates is that the traffic is automatically rejected even before authentication and before any application code runs. So if a server tries to communicate with our server and doesn't have the required and allowed certificates, then that communication channel is stopped right before any other authentication and code run. And now let's check the diagram. So here at each server, you see I have put this certificate icon. Each server has its own certificate. This is for the UI server. And like I said, this certificate must be issued by a trusted and well-known certificate authority. So the browser can easily verify that certificate authority and say, okay, this certificate is indeed valid, so I can proceed with the HTTPS communication with my UI server. These other two certificates, as they are in your own backyard, you can generate them by yourself using Unix tools. So they are not required to be issued by a trusted certificate authority. And how the traffic would happen. So here the browser will try to connect to the UI server, will ask the certificate, will validate it, and everything is okay. Then the connection is established and the application flow continues. Then between these two servers, as here we have server-to-server communication, we have here mTLS, mutual TLS, meaning both servers must have this certificate and each server must know the certificate of the other server. You configure this by taking the certificate of the other server and put it in the trusted store of this server. So when the connection happens, when this server tries to connect to this server first, we'll see, okay, do I know this server, yes or not? If this server's certificate was added to the trusted store of this server, then it's okay, the connection will go. Then again, the other server will do the same for the corresponding server, and only after both security certificates have been validated between the two servers, only after that the communication is established. Security practice number 5. Encrypting your data. So we can encrypt the data either while it's being transferred between servers, and we call this encryption in transit, or we can encrypt the data that is being stored either on a disk or a database, and this we call encryption at rest. As we saw previously, HTTPS and mTLS, they provide the encryption in transit. And of course, they provide against traffic sniffing and of attacks on the traffic that is happening between two servers. So even if a hacker tries to access your data, as long as they don't have the proper encryption keys or the certificates, then they will only see encrypted data, so just gibberish, so they will not be able to do anything with it. With encryption at rest, of course, once you get the data passing through all these servers, at some point you want to save the data for a later use. So that's why you save your data either locally on some files on the disks or in a database. It's up to you. So that's why you must encrypt as well these disks or the databases. Also, snapshots and backups of these disks or the databases must be also encrypted as well. Why would you bother encrypting all these storage mediums? Well, because even if the attacker somehow bypasses your infrastructure and gets the data, it will get the encrypted data, and again, without having the proper encryption keys, will not be able to decrypt and understand anything from that data. Again, how do you enable or set in place the encryption? For the encryption transit, we already discussed. And for the encryption at rest, usually the cloud provider also has these functionalities as well. So in case you have a storage disk or a database solution from that cloud provider, it also has the option for you to encrypt the data on those storage mediums. Usually the cloud providers allow you to encrypt the data using some encryption keys that they provide, or you can also specify your own encryption keys just to make sure in case by some miracle the cloud provider's key storage is hacked. And as for the diagram, I simply added here these protected database icons on each server. So here the storage medium used on the servers are being encrypted. So just make sure to encrypt the working database, but also the snapshots and the backups that you may enable on this server. So here we have again the mTLS communication between these two servers, backend to backend, server to server communication. Here we have the simple TLS enabled by default by HTTPS, and this is happening between the client and the server. And here we have mTLS between the UI server and the backend server, where we specify mTLS communication between the two servers. And the security practice number 6, and this is more like an advice, to choose only reputable cloud providers that offer the most security features out of the box. So as you saw previously, many of the features that I was talking about are being provided automatically by these cloud providers. You can of course host and enable these services by yourself, either by using Unix packages, or you can buy some other third-party services. But it is more convenient and overall more easy and more cheap to get these services from the cloud provider. Also, specifically, it is more convenient to configure all these services between all these layers. As they are all in one place, you can easily manage them accordingly. So look for cloud providers that provide VPC, firewalls for this VPC, the certificates, and of course encryption at rest and in transit. Usually I use the cloud providers from Amazon, Google, and Microsoft because they are very mature and offer all the security measures that you need. They are mature and also offer some other functionalities that you might later need. For example, they provide out-of-the-box functionalities required by regulatory standards. For example, for GDPR, they also provide audits to your systems. For example, most of the regulated security requirements ask that you provide easy and transparent security audits of access to your systems. So that means security access to your servers and access to your applications. So in case of a control, the agents will like to see a full access log on the servers themselves and on the application level. On the application level, they want to see what user accessed what and when, and what exactly did they access, what resource, what record, and what they did with it. Did they delete it? They modified it? They created it? And so on. And all this is provided, of course, by other services offered by these big cloud providers. And also, as a side effect, using the big cloud providers overall will render you paying less for these services than the other, let's say, smaller cloud providers, which in fact delegate and outsource the services of these cloud providers. But those smaller cloud providers, they just provide a simpler access to the services. So my recommendation is that it pays off to learn how to use these big providers. And now another benefit of using these providers is that usually these also come with scripting frameworks. So basically you can create a script on all your infrastructure and then use that script to automatically replicate all the infrastructure to another client. So for example, you have a client where you configure all the VPCs or the servers or the configuration, everything. So then when you have another client, then you could just take these sets of scripts and then run it on the client's account. And all the services, the configuration, everything will be automatically created for you, so you don't have to manually create and duplicate the infrastructure by hand. Okay, now for the bonus part. If you have hardened your n8n server so good so far, if you have applied all the rules and patterns that we discussed so far, you might wonder, okay, if my server is so secured and so inaccessible, then how can I connect to it with the admin interface so I can configure it? Because n8n, as most of servers today, come with an administrative interface, and that is web-based. So how can we access the web admin interface? We have two options. Option one is to use an access pattern usually called Bastion, gemhost, or proxy. What does this mean? Basically, this requires an access server in the same VPC as the n8n server. And this server is called usually the Bastion server or the proxy server. And how can you access this server? You can access it via an SSH tunnel that you can configure on the Bastion server, or through a VPN connection that will give you access to it. And now, of course, you may wonder, if I have this Bastion server in the same VPC, and of course, the IP address of this Bastion server must be public, so I can connect to it via SSH, then that would mean it's like a security breach. No, because you have an entry point, a gateway to your VPC from the internet. That's 100% correct. That's why this option one is the first one, but is not the most secure. We have option two, we'll get into a bit, but still this bash access pattern is still commonly used and it's still very secure because of these security measures in place set exclusively for the Bastion server. It is strongly authenticated, so you can authenticate only using SSH keys. So the password authentication and also root login are disabled. And we have short-lived sessions. What these short-lived sessions actually mean is usually the access session is temporary and automatically expires after a limited time. You can configure this like usually 15 to 60 minutes. Also, the access tokens, the SSH keys, are also temporary and usually expire for, let's say, 30 minutes. The Bastion server is strongly hardened, meaning you can configure it via the firewall to allow only a list of IPs that are allowed to connect to this server. And of course, you open only the 22 SSH port and have a rate limiting in place. With rate limiting, you can enforce rules like maximum, let's say, 5 login attempts per minute per IP, temporary block after 3 failed attempts, and even ban the IP for 1 hour after repeated failures. Of course, the Bastion server is properly logged, monitored, and patched automatically. So this way you know exactly when authorized users connect and when some unauthorized users try to access the server as well. So you can get an alert and then you can block it immediately. But this you should have already done it automatically via the rate limiting rules. But still you can get alerts in case something unusual happens, so you can then investigate properly the access attempt. The Bastion server can be implemented with default Unix tools and scripts, so you don't need to rely on any third-party software. But as always, you can also have an option to securely access the VPC with an option provided by the cloud provider, and we'll discuss that in the next slide on option 2. But first, let's see the diagram of this security pattern. Okay, so this is the diagram we had before with our own VPC. And now you have this new server here inside the VPC. Like I said, it has a public IP because you should be able to connect from the internet from wherever you are. So it needs a public IP. And of course, it has the firewall in front of it, configured the way as we discussed. And then the admin with the proper SSH keys and his configured IP to the server can log into this Bastion server. And when he connects to it via SSH tunnel, he then needs to specify what port is bound to the N8N server. So he already should know the port also for the N8N server to be able to make an SSH tunnel connection to it. And option number 2, we can use third-party providers of what is called a zero trust or identity access providers. So this way you can access the admin UI via an identity-aware proxy. These are providers such as Cloudflare Access, Google IAP, Tailscale, or you can use cloud native session access. For example, Amazon has the AWS SSM Session Manager. And as a comparison to the Bastion approach, which access is given from this IP or origin, with the IP access is given by identity, by this user. So Bastion gives access by the IP or origin, the IP gives by identity. You can think of it for the Bastion, if you are on this IP inside this network, you are allowed. For the IAP, if you are this user and this device, you are allowed. So the IAP provider removes entirely the Bastion server implementation, because even if it's hardened perfectly, it's still, nothing is perfect, so it still has some risks. You have no firewall rules to configure, so no SSH keys to manage. You don't have an attack gateway like the Bastion to be brute forced, and identity is checked before any network access. So you can see there are some operational benefits of using the IP provider. All the access control and audit logs are centralized and managed by this service. You have immediate access revocation in case the identity is not properly provided. And you have a very low risk of misconfiguration because you don't have to deal with so many user and access management as for the Bastion server. Again, as differences between the Bastion and the IAP, you can think of as Bastion protecting the door, and the zero trust removes the door. So the Bastion relies on perfect configuration, and the zero trust removes the entire attack paths. But as a trade-off, these providers are usually paid. And now let's check on the diagram. But before we go into the diagram, just a few words of what I said previously about this device. So the IAP can also check your identity via the identity provider, either Google, Facebook, Microsoft, Okta, depending on whatever identity provider they support. We have the device trust. So what is this device? So to be able to authenticate, the user must provide their identity with the identity provider and to be connecting from a certain device. And based on the provider, they can check whether is this a registered company laptop? Is the operating system up to date on this device? It has the disk encryption enabled. Is the antivirus running? Is the browser compliant? Was this device already previously enrolled? And even some providers require you to have an agent, a client application that is also developed by them, installed as a requirement to be able to connect. Now let's go to the diagram. So here we have the zero trust IAP provider that is completely outside of our VPC. And we have this flow of actions that are happening when a user tries to connect to the server. Then he is automatically redirected to the IAP provider, where he must first identify his identity. So the identity provider configured on the IAP provider is being challenged. So the user must log in with that identity provider. And of course, is encouraged to have multi-factor authentication on your identity provider. For example, on Google, you can have an authenticator app or the tap to authorized authentication, where you have to tap yes or a specific number shown on the screen on your mobile device, or via sending a code via SMS or email. It is up to you. These MFAs are configured on the identity provider, but you should have it mandatory enabled for this user account that you are being used to connect to the VPC. Then after the identity is provided, the IAP checks also the access rules for the user, which can range from specific IPs, ranges of IPs, or countries, or physical location of the user. And of course, the device to be checked, as previously we discussed. And after all these checks are performed correctly, then the user is being redirected to the N8N server. So it is the URL the user tried to access initially when he was redirected to the IP provider. Then, after all the checks, that URL is being given access to, and the user will see that resource so he can actually manage his own N8N server. And as alternative to the third-party IAP zero trust providers, we have alternatives coming from the cloud providers themselves. For example, from Amazon, we have the AWS SSM Session Manager that provides the same functionality as well, but this is provided by the cloud provider. Also paid, so you have to check that out. Maybe most of the times, if the cloud provider gives you already this functionality, maybe it's easier to use it this way, because you have all the security rules, all the user groups, all the identity managers and rules already defined in the cloud provider, and you can easily use those in the session manager. And now some key takeaways. As you know, automation tools are high risk targets because they keep the access tokens and credentials to other systems that you may integrate with. Never expose them publicly. The best way to harden them is via isolation, authentication, and encryption. And like we previously discussed, the best way to secure it is to isolate it, like we discussed via the VPC method with authentication. So use tokens, users, certificates, and of course encryption. And security is about preventing access. So you should not think of it as reacting after compromise. And as previously stated, the more layers of security that you implement, the more hardened your server will be. So at some point, hackers may give up hacking your system if they have much work to do, many security hoops to go over, and maybe some security gates they cannot overcome, at which point either they stop or they can buy services from other hackers to bypass that security gate. So as a rule of thumb, have as many security measures in place as you can. And for the server that you are basically hosting and protecting, always make sure that you update the server regularly, especially with security patches. So make sure that you subscribe to the security alert channels of the developers of the server, so you are alerted and aware as soon as possible. or of course be part of a development group or a community where they inform each other on these types of alerts. And as a best practice as well, when you don't need to configure your server, you should stop the admin UI server and the Bastion server as well, so you won't have any entry points available to be hacked. If you want to see how AI can help your business specifically, you'll find my contact details in the description. I've also included a link to all the diagrams and materials shown in this video, so you can review them at your own pace. I hope you found this guide helpful. If so, I would appreciate a like. If you want to see more videos on how to build and deploy production-level AI for your business, then make sure to subscribe. And I'll see you in the next one.